Imagine surviving a plane crash, only to be seriously injured by the seat in front of you. It sounds impossible. After all, an airplane seat is supposed to protect you. But aviation experts discovered something surprising. A seat reclined at the wrong moment can increase the risk of serious injury, not only for you, but for the passenger behind you. That's why, before every takeoff and landing, flight attendants insist on the same instructions. Seat upright, tray table stowed. Most people think it's just another airline rule. It isn't. That simple request is backed by decades of crash investigations, hidden engineering, and lessons learned from accidents where small details meant the difference between life and death. So why does a few inches of seat movement matter so much? The answer reveals one of the most fascinating pieces of safety engineering hidden inside every commercial airplane. Let's find out. Almost every frequent traveler has heard the familiar announcement. Please return your seat to the full upright position and stow your tray table. Most passengers obey without thinking. Others sigh, wondering why those few inches of recline could possibly matter. After all, airplanes spend most of their journey cruising peacefully thousands of feet above the ground. So why are airlines so strict about this rule only during takeoff and landing? The answer begins with an important fact. Although flying is one of the safest forms of transportation, takeoff and landing are statistically the most critical phases of any flight. Most serious accidents happen during these brief moments, which means every second and every inch of cabin space can become crucial. This isn't about comfort, it's about survival. Interestingly, airplane seats weren't always designed with survival in mind. In the early years of commercial aviation, engineers focused almost entirely on keeping aircraft in the sky. Seats were little more than comfortable furniture bolted to the floor. Very little thought was given to what would happen to passengers during an impact. Back then, crashes were often considered unsurvivable anyway. If an aircraft crashed, people assumed there was almost no chance of survival. But as aviation improved, investigators noticed something unexpected. Many accidents were actually survivable. The aircraft's structure remained largely intact, yet passengers were still suffering severe injuries inside the cabin. That discovery changed everything. Instead of asking only how to prevent crashes, engineers began asking a new question. How can we help people survive if a crash does happen? That single question transformed aircraft design forever. As investigators studied accident after accident, they noticed the same pattern. Passengers weren't always injured because the airplane broke apart. Many were hurt by objects inside the cabin. Loose baggage became dangerous projectiles. Hard obstacles. Seatbacks struck passengers with tremendous force. Suddenly, the cabin itself became just as important as the aircraft. Researchers realized that even a small change in seat position could completely alter how the human body moved during an emergency, and that's where physics comes in. Think about riding in a car. When the driver brakes suddenly, your body keeps moving forward for a brief moment because of momentum. Now imagine that force multiplied inside an aircraft during a hard landing or crash. Even while wearing a seatbelt, your upper body continues moving forward until something stops it. That's exactly why passengers are instructed to adopt the brace position. The goal isn't simply to protect your head, it's to reduce the distance your body travels before impact. aircraft interiors. Modern airplane seats are far more advanced than they appear. They're not simply built to stay rigid. In fact, they're designed to absorb energy during an impact. Engineers carefully calculate how a seat should bend, flex, and distribute force, reducing the stress transferred directly to a passenger's body. But there's one important condition. The seat must be in the position it was designed to protect. An upright seat keeps impact forces flowing through the frame exactly as engineers intended. A reclined seat changes those angles, making the behavior of the entire row less predictable during a crash. In aviation, predictability saves lives. That's why flight attendants insist on checking every seat before takeoff and landing. They're not enforcing an unnecessary rule. They're making sure the aircraft's safety system works exactly as it was designed. Before a new airplane ever carries a single passenger, every seat must pass one of the toughest safety tests in the world. Inside specialized testing facilities, engineers build full sections of aircraft cabins and place them on massive sled systems capable of simulating the violent forces of a crash landing. Crash test dummies, equipped with hundreds of sensors, are strapped into the seats. These sensors record the forces experienced by the head, neck, chest, spine, and legs during impact. The goal isn't simply to see if the seat survives. The goal is to measure whether a human could. Engineers repeat these tests over and over, changing seat positions, adjusting recline angles, and even testing tray tables in different positions. The results consistently show the same thing. An upright seat provides more predictable protection, while a folded tray table removes a hard obstacle that could cause additional injuries during sudden deceleration. These aren't assumptions, they're conclusions supported by decades of real-world testing. But surviving the impact is only the first challenge. What happens in the seconds afterward can be just as important. Many passengers don't realize that every commercial aircraft must prove it can be completely evacuated in 90 seconds or less, even if only half of its emergency exits are available. Imagine hundreds of frightened passengers trying to leave a dark, smoke-filled cabin within a minute and a half. Every obstacle matters. A reclined seat narrows the available space. An open tray table creates another obstruction. Even small delays can cause traffic jams inside the aisle, slowing the evacuation when every second counts. That's another reason flight attendants carefully check seat backs and tray tables before landing. They're preparing the cabin not only for a possible impact, but also for the fastest possible escape afterward. What's even more remarkable is that these rules aren't unique to one airline or one country. Whether you're flying across North America, Europe, Asia, or Australia, you'll hear almost the same safety instructions. That's because aviation has become one of the most internationally coordinated industries in the world. Safety organizations share accident reports, engineering research, and testing data so airlines around the globe can learn from every incident. Instead of repeating mistakes, the industry improves together. Every regulation you experience today exists because investigators spent years studying what happened yesterday. Flight attendants are part of that system. When they ask you to raise your seat or close your tray table, they aren't being overly strict. They're following procedures developed through decades of research and real-life experience. Aircraft design also continues to evolve. Modern seats are lighter, stronger, and smarter than ever before. Some newer designs include energy-absorbing materials that better distribute crash forces. Others are being developed with integrated airbags built directly into the seatbelt, providing additional protection during sudden impacts. Engineers are also studying how passengers behave during real emergencies. Using evacuation footage and accident investigations, researchers continue improving cabin layouts, emergency lighting, exit signs, and even the way safety instructions are delivered. Every improvement, no matter how small, is carefully tested before becoming part of commercial aviation. Comfort is important, efficiency matters, but neither comes before safety. Every innovation must first prove that it protects passengers when it matters most. When you step back and look at the bigger picture, something fascinating becomes clear. An airplane seat isn't just a place to sit. It's part of an enormous safety system designed by thousands of engineers, researchers, investigators, and regulators over many decades. Every angle, every hinge, every measurement, every instruction. Each one exists because someone asked an important question. How can we save more lives? Most passengers never notice this invisible engineering. They simply hear the announcement, adjust their seat, close the tray table, and continue scrolling through their phones. But hidden behind that ordinary routine is one of the greatest examples of engineering every single day. The next time a flight attendant asks you to return your seat to its upright position, you'll know that it's far more than a simple airline policy. It's the result of decades of crash investigations, scientific research, and continuous improvements that have made modern air travel one of the safest forms of transportation ever created. A few inches of seat movement may seem insignificant, yet those few inches represent years of engineering, countless safety tests, and lessons learned from tragedies that helped protect future generations of travelers. Sometimes the most ordinary objects hide the most extraordinary stories, and an airplane seat is one of them. Thank you for watching. If you enjoyed uncovering the hidden history behind everyday objects, don't forget to subscribe for more stories that reveal the remarkable science, engineering, and history hiding in plain